everything about all the heavy lifting, we covered. I now want to tell you about some of the new AI services, artificial intelligence services. So same topic in a way, but here we're going to talk about services that are very high level, do not require any machine learning skill. It doesn't mean that if you do have machine learning skills, you don't have to use them, of course. If a problem has been solved in the industry, why not? Why reinventing the wheel? To be honest, that's my take. So we saw what the stack looks like. We want to focus on the top right here, and there is a lot at this level. I will focus on the new stuff, but the new stuff is only 3 or 4 services. So I also wanted to give you an overview of what was already there. Stuff like Amazon Recognition for image and video analysis, stuff like Poly for text to speech and speech to text, Transcribe, the opposite, Comprehend for natural language processing and natural language understanding, Translate, and Textract for document digitalization. There is a lot of very granular services that solve very specific problems. Amazon Lex, Amazon Personalize for content recommendation, Forecast for time series forecasting, Fraud Detector for detecting frauds on your e-commerce. There is a lot. I'm going to tell you what's new, and I'm going to start with a new set of services that are specifically targeting the world of manufacturing and industrial manufacturing and IoT, wherever you have industrial equipment, for example. So one of the main launches this year in this space was Amazon Monotron. So imagine you have a production factory, you're producing whatever product, and you have equipment that needs to be monitored for, vibration and noise and, whatever kind of, critical thing that equipment needs to be monitored. So Monotron is an end-to-end solution. So we give you the hardware, the sensors for noise, for vibration, for everything. You attach the sensor to your equipment, and then this equipment talks to a local gateway, which talks to the cloud, which talks to a mobile application that you can use to monitor your equipment from wherever you are. So it's a completely end-to-end solution for industrial monitoring. In case you already have the sensors in place, because it's a typical problem that maybe many companies already have a lot of sensors for vibration and sound and other metrics. We launched something slightly different, which is Amazon Lookout for Equipment, which does the same. So the backend, in a way, is very similar, and it's a fully managed service, but you can integrate your own equipment data from the sensors that you already have installed and deployed and used in the past, maybe. So it's kind of a anomaly detection service specifically for industrial equipment. And the goal here really is not just to look at the data and be happy about it. The goal is to enable, for example, predictive maintenance, because you don't want to wait for industrial equipment to break down before you notice something is wrong. You want to detect these anomalies, days or weeks before it actually breaks, so that you can go into maintenance and kind of avoid downtime. As a factory, you don't want to have even 1 day or sometimes 1 hour without producing stuff, because that means you are stuck, or your processes or your continuous processes to produce and deliver whatever you're producing, it's stuck for hours or days. So you don't want that. This is a good way to prevent that situation. Panorama does something slightly different. It's a new, it's actually multiple things. It's an appliance. It's basically a smart camera that you can deploy in the same context. So we are talking about industrial manufacturing, that world where you need to do, similar task, but visually, right? Again, to enable predictive maintenance, to have a look at the environment, to make sure there is no issues or defects in the products, for example. So you can deploy your machine learning models at the edge on this appliance, on this hardware, which is basically a very smart camera that can run your machine learning and deep learning models right there at the edge without talking to the cloud. And it's not just appliance, it's also an SDK. So if you already have cameras that are not too smart, but smart enough, you can actually integrate them with the Panorama SDK. Or maybe if you are a camera manufacturer, you can already embed the AWS Panorama SDK in your cameras so that whoever buys them can easily integrate with the AWS cloud too. And another interesting service, which is part of the Amazon Lookout family, it's kind of a new family for anomaly detection, is Amazon Lookout for Vision. So here we're talking about anomaly detection with images. Okay, so similar context, we are maybe producing something in an industrial, we had an example like a customer was producing pencils, or a customer is producing t-shirts or whatever industrial fashion, and you want to take a picture of the whole item, the whole product, or maybe a section of the product to make sure that there are no defects, again, to automate and improve the quality of the products that you are producing. So again, fully managed service. You don't need to know anything about math, engineering, statistics, or computer vision. You just provide the images. We say at least 20 or 30 images, and then you label the data and you say, okay, this is a defect, and no, this is not a defect. And you provide enough images, and then an anomaly detection model is produced. So let me show you what it looks like. So it's not very abstract to you. Let me show you a real example. So here, just to use a real data set from, it's a few years ago, but this was an industrial manufacturing data set where they were taking pictures, 500 by 500 pixel images of these industrial textures. I don't know if it was what the product was really. It's probably some kind of steel or some kind of texture. So there are actually multiple classes of defects, and I'm just going to pick one. So the class 2 is what we care about. Let me show you what class 2 is about. I have it somewhere here. Yeah. So class 2, there are about maybe 1,000 images, and they look pretty ugly, but these are images without a defect. This is what the pattern is supposed to look like. Let me show you what a defect looks like. And as a human, it's pretty clear. Okay, this is probably a defect in the pattern or in the production process, or in a, maybe there was a mistake, a human or a machine made a mistake. So there are a lot of examples, about I think 150 examples of these defects. So we're going to use this as our data set. I've already uploaded it to S3. And so I have the class 2 folder, the class 2 with defects folder, and I've already split my testing and my training set just randomly. I think 20% testing set, 80% training set. So this is something you still need to do. So the service is not doing that for you automatically yet. And once I have that data on S3, Amazon S3, our object storage, you could just go and create, let me get rid of Zoom, and you can create a new project. Okay, you just give it a name, and there you go. So you create a data set, you add the labels, you annotate your data set, then model training starts. It will take 10 minutes, 20 minutes, kind of depends, could be an hour and a half if we have enough images. And how do I create a data set? So you can create a single data set or already split it between test and training. You can upload it from S3, so it's already on S3, like our case. You can directly upload it from your computer, or you could even import it from another service that I think Giuseppe mentioned it. It's called SageMaker Ground Truth. It's a feature of SageMaker that allows you to upload unlabeled data and annotate it, basically, managed user interface. You can do it, your colleagues, your teams, or even a third-party vendor can do it for you. So if you have annotated a data set using ground truth, you can also import it here and just use it right away. We have it from S3, and I'm not going to do it again. I already did it. So let me show you what it looks like once you have connected to S3. So now I have my images. There are about 900 images. They are all labeled already, so I don't have to do any manual work here, but I could, right? So I can add more images to the training or the testing. If there were any unlabeled images here, I would be able to label them and say this is a normal product or this is a defect, so an anomaly. And once I have my model going, this is the model I trained a few days ago, and pretty good, right? 100%. Okay, so this was a lot of images, not just 20 or 30. This was more than 900 or 1,000 images in total. So not a small data set, but if you have a production factory, you probably have more than 1,000 images. Most of the work is annotating them, right? So without knowing anything about anomaly detection or algorithms for anomaly detection or computer vision, I get a 100% accuracy model. What can I do with it? Well, super simple. Wait, where is my Visual Studio? Here we go. So once I've done all the work, I can actually just start my model, meaning I start the hosting of my model because I pay by the hour of model hosting. And then I can simply invoke this API here. So this is using the AWS CLI, but you can absolutely use the Python SDK or the Java SDK or whatever programming language that has an SDK. So you just say detect anomalies for your project, for your version, because you can have multiple versions of the same model. You provide the image, in this case, a local file, and there you go. It will tell you yes or no, basically, in a JSON structure. So pretty simple, very high level. Every developer can integrate this into any application, seriously. That's it. Let me go back to my slides. And then there are other cases where you still want to do anomaly detection, but not on images. You want to do anomaly detection on metrics, maybe business metrics or operational metrics. So basically numbers, right? So how do we do that? There is another new service. It's part of the new Lookout family. It's called Amazon Lookout for Metrics. Very, very, very similar concept, very few differences here. The major difference is that you don't provide images, you provide a data set that is numeric, so like a CSV file or a JSON file. There are more than 25 connectors, so your data could be on S3, but also on many, many other places. So let me show you what it looks like too. So we do some hands-on tonight. So there is a data set that you can use if you want to run an experiment. It's on GitHub, it's public, everybody can have a look at it. It's Amazon Lookout for Metrics samples. Just Google this. You click on Get Started, and here you find a data set. It's just a few megabytes. It's an e-commerce use case. So we have page views and revenues from different countries, from different device types, stuff like that. Completely anonymized data already. Okay, that's kind of what you want. I have already uploaded this data set to S3. So I have two different folders. One is for backtest or historical data. So there are cases where you just want to look back at the last 2 or 3 months or 6 months and see if anything weird happened, so you can act in the future. In other scenarios, you want to monitor live data. And in this case, maybe every hour or every day you have new data and you want to automatically identify anomalies in that data. So two different use cases, but you can actually use them together if you want. You can say, I have live data, but I want to use historical data for the training as well. So it's even more accurate. So let me show you what the data looks like. Wait, I think I have it locally somewhere, so I can show you a preview. Downloads, e-commerce. Yeah. Okay, now this is huge. Let me show you a smaller file. Yeah. So this is what the data looks like. Very few fields, super simple case. We have basically views and revenues. This is what we want to track and see if there is any anomaly in those two metrics. And then we have platform and marketplace. These are our dimensions, if you want. So we could be PC web or mobile web for the platform. So where is the data coming from? Or marketplace is basically the country. It could have been country. So you have US, UK, Germany, France, Spain, Italy, and so on. So we receive this data every hour. So I have a record for every dimension and combination every hour for views and for revenue. That's the data we are starting from, okay? And your data might be different. I'm just trying to explain this example. So what do I do? This is Amazon Lookout for Metric. It's still in preview, but you can request to join the preview and start using it. So, you know, it's a preview. It's not 100% perfect, but it works. So I just created a detector, my historical detector. I say that I get new data every hour, and I just create it. Next, I am going, so this is kind of the flow. You add a data set, then you activate it, so it starts the training. I can automate the alerts as well, and after the training is completed, I can go and view the anomalies. So let me show you how to add a data set, my historical data set. So there are a lot of places where your data could be, not only native AWS services like Redshift or RDS, you know, Postgre, MySQL, MariaDB, but also, you know, S3, but also a lot of third-party applications and third-party platforms that you can import very easily via Amazon AppFlow, which is just a way to integrate third-party data into your AWS workflows. So we're just going to use S3 because that's where my data is already. Here I can pick backtest, which means historical data, or continuous, which means live data coming every hour, every day, or every week. I say, where is my data? It's on S3. I cannot remember the bucket name, so I'm just going to copy it here. And the folder is backtest. That's where my data is. It's only one file, 2 or 3 megabytes of data. I can pick the most recent date. So if there is any data, in our case, there is some data in the future and we don't want to use that for training. And then I can configure, you know, it's CSV, it could have been JSON. You can configure all the delimiter, header, quotation, you know, all this stuff. Here you just specify the role that the service is going to use to access your S3 bucket. By default on AWS, you know, services cannot access each other. You need to explicitly provide permission to do so. Otherwise, you know, for security, we don't want that access open by default. So the data was validated. The data was already read and categorized. You know, you see all the fields that we talked about. So I don't have to do any manual work here. What I need to do, though, is to map my fields into measures and dimensions. This is pretty intuitive. You know, what's a measure? We talked about it. We have our views and our revenues, and we care about the total number of views and the total number of revenues. There are other cases where, for example, if this was a, I don't know, CPU utilization metric, you know, you don't really care about the sum, you care about the average over time. So there are other cases where you want to aggregate with an average instead of a sum. Dimension, we have platform and we have marketplace. Pretty easy. Timestamp, we only have one timestamp and it's a 24-hour format. So we configure the format. Once that is done, I can just save and activate my detector. So it does more work than Lookout for Vision because it's already doing the 70%, 30% split of my training and testing sets from my historical data. So I don't have to do that manually myself. And now the detector is activating, so it's basically training. It will take a while, so I'm not going to wait. I already have a detector. Actually, no, let me take the historical detector. This is already trained. I did it this morning, so I can show you the anomalies. So pretty important thing, you have one severity score threshold, okay? It's not one threshold for each metric, which is usually what happens. If we have views and revenues, maybe you would end up with a lot of different thresholds to configure for your anomaly detection. Here we have one severity score that applies across all our measures. So each anomaly that was found, detected, has a severity score, and we can even sort by severity and have a look at the date it was detected, and we can have a look at what the impact analysis looks like. So you have some summary data. You can see what metrics were impacted. In this case, it is views. You can see what dimensions were impacted. So the marketplace, Japan and Germany, and the platform is mobile web. So what happened? Why? This data is supposed to help you figure out what happened, what went wrong. Was it a network issue? Was the website down for customers in Germany? Was it a problem with the web application? Here you have the data that shows you what's the correlation between all the different dimensions and metrics. And you also get a nice visual representation. Okay, so this was the pretty nice pattern hour by hour, and then at some point goes up. Okay, so here I can provide feedback. Is it relevant? I don't know, it went up a little bit. Okay, I don't care, so no. While in this case, this is page views in Japan from the web application, it just went down abruptly. So this is relevant. So I'm going to say yes, and I can provide feedback so that human in the loop feedback improves the model over time, especially in the case of continuous anomaly detection. That's it, guys. Pretty simple. This is supposed to help business owners, developers, operations managers to find the issues, eventually get notified. I didn't show you, but you can add alerts. So for example, you could say, if the threshold is above 80, ping me on Slack in this room, in this channel. If the threshold is above 90, send me an email. If the threshold is above 70, just send me an email, or I don't know, invoke a Lambda function to do something custom, maybe to put the data into a database or to do something that is not supported yet. So pretty cool. And that was the demo. Let me go back to the PowerPoint. Are there any questions, by the way? Let me have a look at the chat before going ahead. Good question, Joseph. What models do we use for predictive maintenance? That's the beauty of it. I don't know, and I don't care. This is a managed service. It's a black box. You're not supposed to know what happens. What models, what algorithm, what framework. It's an API. The beauty of the largest majority of these artificial intelligence services is that you are talking with a web API. You really cannot look into it. There are exceptions here and there where you can decide the algorithm, like in Amazon Polly, where you do text to speech. You can select, for example, if it's a neural text to speech algorithm or not. So the quality might be different, and you can have a look and here and see which one you prefer. But in the general case, you don't really have control, or you shouldn't really care what algorithm or model is used under the hood. Okay, any other question? Not yet. Cool. let me go back to the presentation. We already had Amazon Forecast. It's a service, very similar approach, provide a data set, a custom model is built for you. You don't know how or why or with which algorithm. And then you get a time series prediction model custom built for your data set. So Amazon Forecast, it's been out there for a year. Yes, for a year and a few months. What was added was an integration with the Amazon Forecast Weather Index, which means that you can optionally include weather information in real time into your prediction. It's pretty common that you use Amazon Forecast for retail or e-commerce or delivery situations where you need to stock products in a warehouse, for example. And there are situations where you want to integrate additional relevant data, like if there is any promotion going, or for example, what's the weather out there. And believe it or not, it does have an impact on the forecasting. So it was integrated. It allows you to integrate it with a click instead of taking care of that and integrate this custom data into your data set. Another interesting feature that was added to solve an interesting problem, if you want. This is becoming more and more common, that human beings want to interact with computers using natural language. Okay, this is super common. Maybe you want to talk to a computer, or you want to ask a question to a chatbot, stuff like that. So we tried to merge that experience with the context of data exploration and data visualization and dashboards and stuff like that. So Amazon Quicksite already existed. What was launched and announced was Amazon Quicksite Q. Q is a new feature of Quicksite that allows you to talk to Quicksite, or basically ask a natural language question in order to generate a chart. So Quicksite allows you to do data exploration. You can build dashboards. You can dive deep into the data and do stuff like that. Let me show you an example. So imagine that we have this simple data set. We have sales data across different states in the United States, and across different selling categories like retail, like outdoor clothing, toys, and so on. So what I want to be able to do with Quicksite is that, I want to, for example, show me only the data related to California in 2019 or in 2020, like last year. So what would usually happen is that, okay, this dashboard was built by a BI, like a business intelligence team. So I would need to say, hey, can you please get me this data as soon as possible? And they come back and say, sure, in a couple of weeks, no problem, because they need to build some custom dashboards and they have their own processes. So what we want to do instead is to just say, hey, Quicksite, just show me the sales of last year weekly in California. Okay, this is a typical query, and your data set might be different, but we want to get that chart that quickly, and maybe we want to compare it with another state like New York, and this could be in Italy, I don't know, Lombardia and Lazio, right? Just geographies. And we can see the data, we can take a screenshot, or we can add it to a dashboard. Pretty simple to ask something custom, but also there might have been 100 different ways to ask for this. Here I ask for sales, but I could have asked for weekly revenue, California versus New York in 2019, and I got exactly the same result. That's because Quicksite Q is trained to work with multiple terms, and what typically happens is that different teams in an organization uses a different language, uses a different terminology. Like in a team, that's revenue; in another team, that's sale. And so, you want to be able to generate the same chart and to kind of standardize and make sure everyone can access the same data independently and quickly. But not only that, let's see what what else we can do. So for example, we may want to ask something different. Like we may want to ask what are some of the best selling categories still in California, but I want to show the different categories. So maybe kitchenware and outdoor were pretty popular, but maybe I don't like this visualization. I want to see it in a histogram. Okay, I see that gaming was kind of underperforming, so I want to dive deep into gaming. So I just change questions, like show me the weekly, the monthly gaming. And as you can see, even though there is basically magic here, Quicksite Q is just suggesting me the category name, right? So pretty powerful. And then I can ask the revenue for the last 3 years. And I also mistyped California, as you can see. So, and I asked for revenue. And the translation of that was, okay, show me the sales for the gaming category in California in the last 3 years. And California was detected, revenue was transformed into sales. Everything kind of worked magically. So that's kind of the power that you want to give to your internal teams in an organization to go and do data exploration without knowing almost nothing about the data set. And as usual, you have that human in the loop feedback where you can say, okay, this looks good, it doesn't look right, so that Quicksite Q improves over time as well. So that was Quicksite Q. Last topic I want to touch on is contact centers. Maybe you've heard of a service called Amazon Connect. If you have never heard of Amazon Connect, it's basically a contact center as a service. So it's kind of like a call center as a service. You don't have to install any software, you don't have to install or provision any hardware or any infrastructure, virtual or physical. Basically, it's just an API. That's why it's kind of in this area of smart services. And it's pretty smart because it can do a lot of smart analysis of these conversations that customers or whoever is calling you is having with your agents. So you might have human beings talking to each other, but you may also have human beings talking to a chatbot, with voice or with text. So in a chat, for example. So it's pretty powerful solution. And there have been a few very, very interesting additions that are somehow related to artificial intelligence and machine learning. So these are the 5 new features. They are called Connect Voice ID, Contact Lens in real time, Tasks, Wisdom, and Customer Profile. So they are kind of connected to each other, and maybe you can have an intuition of what they do. For example, Voice ID is what you think it does. So you can create actually, let me go on and show you. So you can basically create like a voice signature of the customers or whoever is calling you, so that they are automatically detected when they start a conversation. And basically all the features, all these 5 features, have the final goal to improve the productivity of the agents that sit under the call center. So imagine that all those tasks that need to be done before, during, and after the call can be automated or improved in terms of speed a lot. So Connect Voice ID will just do that and will give the agent a prompt about, okay, I think with this confidence that who is speaking is this customer. Okay, do you require human validation? And basically you have that optional automation. Of course, you don't have to enable it, but it can speed up the conversation by a lot. Customer profiles, very similar, and it can be integrated with the Voice ID. Basically, it's a functionality that's able to fetch all the contact history, the address, the phone number, all the orders, or the historical data related to that customer from multiple data repositories. And basically, as an agent responding to a phone call, imagine that in 2 seconds, while the customer is saying, good morning, I'm here because I have a problem, and blah, 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 you already have all the data of that customer under your eyes, and you're like, sure, okay, I can see your order, click there, fix the problem in 10 seconds instead of 10 minutes. So that's kind of the magic that you can do with this. And wisdom, in my opinion, is even more powerful because it does actually a language analysis on what the customer is asking or what the customer is saying, so that if there is a match in a repository of FAQs or default instructions or a Wikipedia instructions that you have internally, it can prompt that information to the agent. So he or she doesn't have to look for that information in 100 different places. It just pops. So pretty magical too. And tasks similarly allows the agent to automate some of the tasks that typically need to happen during or after the call, like sending an email or checking a task in a task list and stuff like that. So you can easily automate those tasks and improve the efficiency of your agents even more. And the last one is pretty fascinating because contact lens for Amazon Connect is basically a natural language analysis tool for these conversations. So you can do data exploration and visualize, for example, the emotion during the phone call, and have a transcript because it does speech to text transformation automatically, if you want. What was added, this already existed. What was added was the ability to do that in real time during the call. So you have stuff like emotion detection, emotion analysis during the call. For example, you can create warnings or alarms and escalate the call to a supervisor or to a manager, in the back end, whenever like maybe a keyword such as like unacceptable or cancel my subscription, stuff like that. Situation is out of hand, and you can configure it to automatically escalate or alert managers or supervisors to take control of the situation and fix the problem. So again, pretty useful tool to improve the user experience of whoever is calling you. It could be a customer because it's a customer support call center, but it could be other use cases too. And also, on the other hand, improve the efficiency of your agents, because if an agent doesn't need to spend 10 minutes before, during, and after a call, it means that they can take 2 or 3 or 4 times as many calls in a day. So that's a pretty good improvement. I don't think you can see this, it's pretty small, but this shows you the language support of Amazon Connect contact lens, and for which languages it supports real time and other features too. So for example, for Italian, you can see it here. It supports Italian in the post-call analysis, but it doesn't support Italian or actually any language other than English for the real-time analysis for now. So maybe wait a few more months, and I hope it comes pretty soon for Italian and French and Spanish and all the other languages too. And that's all, folks. I hope you enjoyed it. The services we talked about in this session are not, the full list of services, artificial intelligence services. There are another 10 that we didn't talk about. I only mentioned a few, and I hope you really like the new services that I presented and some of the demos as well.